Hello guys, today we study section 14.3. It's section about how we solving integral when we change variable. And here we we use polar coordinate system. Sorry. First we see some theorem tell us if you have integral, double integral, rectangular coordinate system x, y, dA, and you want to move polar coordinate system, and you can rewrite your region, use some function which depends on polar coordinate system, then we move where is theta changing from alpha to beta, interior integrals, and r changing from some function g1 depend theta to g2 depend theta. But we'll be careful. Here is very interesting. X you substitute with r cosine theta. Y you substitute r sine theta. It's not 0, it's theta. And not only the r d theta, here we have r, the r d theta. Be careful about this r, don't forget. This is theorem show us how we can moving from rectangular coordinate system to polar coordinate system, from double integral to interior integrals. See some example. Let's go. We need evaluate integrals from region R, x squared plus y dA, whereas our region is some region between two circles, one of x squared plus y squared equal 1, second one x squared plus y squared equal 5. This means my region is, I have two circles, one, and second one, here is 1, and this is square root of 5. Okay, how it's changing? Double integral, interior integral. How it's changing my theta? Because it's whole circle, this means angle change between 0 and 2 pi. How it's changing distance between our center to our point, because it's point who stays between these two circles. Yes, this point, and this point stay in distance between our center. It's from 1 to square root of 5. This means r changing from 1 to square root of 5. Here we're plugging for our function new variable. X squared will be r squared cosine squared theta. Y will be r sine theta. Then you remember in formula we have r, and you remember in the formula we have r dr d theta. And this is integral. It doesn't have problem, but we continue solving. First okay, I'm checking this part. We have integral from 0 to pi, from 1 to square root of 5. We have r cubed cosine square theta plus r square sine theta dr d theta. This means I multiplied by our r. Now is integral from 0 to 2 pi r cubed. Oh, sorry, my mistake. What is will be integral here? R fourth over 4 cosine squared theta plus r cubed over 3 sine theta d theta. And for r we need plug in number from 1 to square root of 5. It will be square root of 5 fourth degree. It will be 525. This means 25 minus 1 over 4 integral cosine square theta d theta 0 to pi plus 5 square root of 5 minus 1 over 3 over 3 integral 0 to pi sine theta d theta. Because we have cosine square here, we use our formula for twice angle. This means 1 plus cosine 2 theta over 2. And final 25 minus 1, 6. This we have 3 integral 1 plus cosine 2 theta d theta 0 to 2 pi plus maybe I'm integrate now. This means I have minus 5 square root of 5 minus 1 over 3 cosine theta 0 to pi. Finally finish please, and final answer here will be 6 pi. 6 pi. I think this finishes no problem, and you can do it yourself. Okay, see one more example. First I clear my table. And see one more example help us how we can solving. Sorry, it's taking more time than planning. How it's we can integrate our integrals, guys. And one more, please write if you have any question. Will be free. Write your question at Blackboard or email me in my email. Okay, making one more integrals. Here I take it from book, it's number 18. It will be, we have double integral from 0 to a and from 0 to square root a square minus y square function y dx dy. First we found some region. For what region we solving? Because variable differential here is we have order dx dy. This means x changing from 0 to x changing from 0 to square root a square minus y square. We can easily see this means we work with some circle, some part of circle, radius a. Okay, I'm write whole circle. And what we have here, because x is positive from 0 to border our circle, look at second part, y, how changing variable y? It's how changing border, it's your first integral from 0 to a. Y change from 0 to a. X change from 0 to borders. Whereas it's intercept all of them. This means you have, this is your region. If we move to polar coordinate system, our angle change from 0 to half of pi. This means theta changing from 0 to half of pi. Radius change from 0 to a, because our circle is radius a, from 0 to a. And now we have y is r sine theta, dx dy we move, this means our theorem we have r dr d theta. And counting this integral is no problem. I think for all my student, I'm absolutely sure 0a, it will be r square sine theta dr d theta. This will be 0 pi over 2 r cube over 3 sine theta. It will be a cube over 3. Integral sign is negative cosine. This means I'm plugging here cosine theta. Where is theta? From 0 pi over 2. If you plug pi over 2, it will be 0. If you plug 0, it will be 1. You need subtract. You have minus. This means finally you have a cube over 3. Okay. And last example, when I want to show you, this is example from book 2. It's similar with your homework. Now I'm checking, please. Just a moment. I need clean here. Okay. Here we have some two integrals. One of them 0 to 5 sorry, maybe I write a little bit lower and it will be work better. 0, 5 square root of 2 over 2. Second integral border 0 to x. Here we have function xy dy dx plus second integral from 5 square root of 2 over 2 to 5, and from 0 to square root 25 minus x squared xy dy dx. We need sum these two integrals, move to polar coordinate system, and maybe with two integrals write this together and see what happened. And first we need checking our region. Looking here, now I cannot write these two integrals together is because we have inside integral have different border. You cannot rewrite like one integral to continue to another. But see our region, what we have here. Looking for first integral. Variable y changing from 0 to x. This means I have line y equal x. And x changing from 0 to 5 square root of 2 over 2. It's some number. What we have here? Here we have variable y change from 0 to part of your circle, because if y is equal square root 25 minus, if y is equal square root 25 minus x squared, this means x squared plus y, y squared equal 25, right? Okay. Now let's go, it's part of circle. Now see intersection point. But intersection point, whereas x and y is equal, this means 2x squared equal 25, and x will be 5 divided by square root of 2, or 5 square root of 2, divided by 2. This means exactly our up border for first integral and lower border for second. This means what will be first region? First region is this kind of region. It is region 1. What about second integral? Second integral is x changing from this point to until 5. This means exactly this part. And we have, now we can write integral for, this is blue one, is region 2. But this two region is not intercept, and but together is covered region R. One we can write, use this fact. Okay, I'm changing my color. First I'm clear here, because you have this writing. Okay, and what is our region R? It will be region R1 and R2 together. Okay, it will be, if we're moving for polar coordinate system, then is theta change from 0 to pi over 4, because we have line y equal x is exactly bisectors first quadrant, and r changing from 0 to 5 because our circle is radius 5, 0 to 5. And now we have x, y, this means r cosine theta times r sine theta. Use our theorem, we have r dr d theta. And you see two scary enough integrals. We use polar coordinate system, we move to one very simple integral. We can do it, we can continue solving. It will be integral from 0 to pi over 4, integral from 0 to 5. Here you have r cubed cosine theta sine theta dr d theta. It will be integral from 0 to pi over 4. Oops, I say pi over 4, but I write pi over 2. Looks like. Okay, check. Pi over 4. R force over 4 cosine theta sine. Oops. D theta equal, and here we need plug numbers from 0 to 5. It will be 625 over 4. Integral from cosine theta sine theta, if you use u substitution and substitute sine theta like u, it will be cosine theta d theta, it will be du, it's mean u square over 2, this means sine square theta over 2. When you need plugin, 0 pi over 4. And if you're counting, you have, if I'm not make mistake, 625 over 60. We're done for today. Doing your homework, write your question, ask me, and I think about how we can do it our office time. Maybe we do it tomorrow or Thursday. If you have any idea, I think we do it in the Zoom. If you have any idea, we try doing. Okay, good luck.